Hey y'all, here with another lesson today. We're going to talk about special right triangles. So just to review what we do know about our triangles already. The biggest relationship we have so far with our right triangles is this idea that if we have one side, two sides, three sides, we have a relationship between these three sides. We have A, B, and C. We know that if we take the square of A, we add it to the square of B, we'll actually get the length of C, or our hypotenuse, squared. So just to remind you, the hypotenuse is always going to be the side that is opposite of our right angle. So notice how C is opposite of that right angle. We are good to go. So the relationship we had for this is A squared plus B squared is equal to C squared. And so if we were given two of our sides, we could always find the third one through this formula. We also learned about some specific trig formulas. If we had an angle and one of the sides, we could actually find the other three. And this was following SOHCAHTOA, SOHCAHTOA. And so this S stood for sine, the C stood for cosine, and the T stood for tangent. And these were three trigonometric functions that we used in order to relate a right triangle's angle to the ratio of two sides. So we found out that if we had our small right triangle, I'll even do it in a different orientation this time, something like this. We had an angle here, theta. So remember, this is called theta, Greek symbol. It's the angle. We would have the opposite side, our hypotenuse, which is opposite of the right angle, and our adjacent side right here. So sine can be written as the ratio of the opposite side over the hypotenuse. Cosine of theta can be written as the ratio between the adjacent side and the hypotenuse. And then finally, tangent of theta, tangent was our opposite side over our adjacent side. And remember, these are just functions, so remember what a function is. We put a value into it and out pops another value. So this is a calculator problem. If your angle was 25 and you wanted to find the tangent of 25 degrees, you would put in this angle. Your calculator would run through all the mathematics behind this. It's a little bit out of our scope for this class. And then out comes a value that represents the ratio between our opposite side or our adjacent side, or it compares these two and says how large is the opposite side when we compare it to the adjacent side. Cosine is how large is the adjacent side when we compare it to the hypotenuse. Sine, opposite to hypotenuse. So today what we're really talking about is two specific kinds of special right triangles where we can show it with this. We can show that the angles correlate to the ratio right here, or we can just remember a few specific values. So our first one is the 45, 45, 90 triangle. So 45, 45, 90 degree right triangle. So if you ever run across a triangle that looks like this, it's going to have something like this, it's meaning you have your 90 degrees, or angle right here, and then both of these are 45 degrees. So if you ever see something like this, there's a specific ratio going on. If I have these two being the same length, which is going to be a consequence of having two 45-degree angles, then this is going to be x times the root of 2. And we can see that through the Pythagorean theorem. X squared plus x squared is 2x squared. And then we take the square root of that to get just our c. And we have the square root of x squared, the square root of 2. And I'll even write that down to prove it. So we have x squared plus x squared should be 2x squared. But remember, this is equal to c squared. So if we wanted c, then we take the square root of 2x squared, or root of 2 times x, okay? So now let's do an example of this specific right triangle. I'm given a right triangle with a 90-degree angle, and one of them is 45 degrees. And I want to find this if my x value is equal to 3 times the square, or if my hypotenuse is equal to 3 times the square root of 2. I want to figure out what these two values are. Well, in looking at this, we know this angle is 90, this angle is 45, so this one also has to be 45 degrees because we know a triangle's angles add up to 180. So the sum of these three, 45 plus 45, 90, plus 90 is 180. We're good to go. But look, we have our right triangle. So we know that 3 root 2 is equal to root 2 times x when we're comparing it to our general form. So that means our x has to equal 3. If we replace this, we want this to be a true statement, or they're the same thing. So we know that this one has to equal x, or 3, and we also know that this mystery value has to equal 3. And that's all there is to it, just noticing that this special right triangle is going to have a relationship between the length of its legs and the length of its hypotenuse. So that's the first one. The second one is also pretty useful. We have what's called the 30, 60, 90 right triangle. And so for this one, it's the same idea. We have 3 sides that always have a common ratio between them. So we can draw out our triangle. I'm going to draw it out in a different orientation so we can see. What's going on here? So we have our 90-degree angle, and then we're going to have our 30-degree angle over here, and our 60-degree angle over here. And so the relationship between these is that if the side adjacent to our 60 degree is equal to x, then we know the side adjacent to 30 is going to be x times the square root of 3. And so if we have these two values, let's see through the Pythagorean theorem what this would give us. So a squared plus b squared times the square root of 3 squared. So this should give us a third part. So we have is equal to c squared. So x squared plus 3x squared, square the 3, square the x, multiply them together, is equal to c squared. Or 4x squared is equal to c squared, but remember we have to take the square root to find this hypotenuse. So we know that c is equal to the square root of 4x squared, or the square root of 4, which is 2 times the square root of x squared, which is x. So this guy over here is 2x. So if you ever see a 90 or a 30, 60, 90 right triangle, and you have one of its sides, you automatically know all the other sides based off this relationship. So let's do one last example of this. Let's see, does the blue still work? No, that's a little light. Let's do it in, I know you guys had, we were having issues with green. Let's just do it in red. So for this example, I'm going to kind of squeeze it down here just so we can keep it on one page. So for example, we are going to have a 30, 60, 90 right triangle. We're going to have our 60 degrees over here. Say we get something like this. Similar to what we did in our last example. We're only given two parts of our triangle, or two angles, and in addition what we're given is that this value right here is equal to 5. And what we want to find out is what is this value right here, as well as what is this value right here. And so in order to do this, we need to fill in our triangle and completely make sure that this is a 30, 60, 90. So 90 plus 60 is going to give us 150. We're going to need another 30 in order to complete our triangle. So notice how we have our 30, 60, 90 right triangle. We compare that to our triangle right here and should notice that our x is actually equal to 5. So that's going to be useful. We can even rewrite it right here because we know that there's a relationship that has to do with that x for all the other ones. So let's start off with the second leg. We know that this question mark is actually going to be equal to x times the root of 3, or we have 5 root 3. So this thing right here equals 5 root 3. It was just noticing that we would have to multiply our value right here by root 3. So that's our first conclusion. Second one is that this mystery value right here is going to be whatever our adjacent side to the 60 degree was times 2. So we identified that our original x value is 5. We're just going to multiply that by 2 to get a value of 10. So that's what this side's going to be. So we have 5, 5 root 3, and 10. So this stuff really comes from what's called the unit circle. We're going to look at that a little bit later on. But these are actually very important and crucial angle measurements to know. And these special right triangles pop up everywhere. So understanding that there's one for the 45, 45, 90, as well as the 30, 60, 90. Remembering back here with your Pythagorean theorem, as well as some of your basic trig functions, and you more or less have everything, all the tools you need in order to be successful in trigonometry.